Day 378 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2094, finding three-digit even numbers. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array digits where each element is a digit. The array may contain duplicates. You need to find all the unique integers that follow the given requirements. The integer consists of the concatenation of three elements from digits in any arbitrary order. The integer does not have any leading zeros. The integer is even. For example, if the given digits were 1, 2, and 3, integers 132 and 312 follow the requirements. Return a sorted array of the unique integers. All right, y'all, so let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input digits equals an array of integers 2, 1, 3, and 0. The output is all possible combinations of those digits of even numbers. So the output is an array of integers 102, 120, 130, 132, 210, 230, 302, 310, 312, and 320. Explanation says all the possible integers that follow the requirements are in the output array. Notice that there are no odd integers or integers with leading zeros. So let's go through this one more step just to make sure that we have a good understanding of what's going on. So first we have these integers 120, 130, 102, 120, 130, and 132. Those are all of the even numbers that we can create with 1 when 1 is the first number. Boom. Then we have 210, 230. Those are all of the even numbers we can create when 2 is the first number. Then we have 302, 310, 312, and 320. Those are all of the even numbers we can create when 3 is the first number. And once again, the integer cannot have any leading zeros, so we don't need to make any numbers that when with 0 being the first number. So boom. Now let's go ahead and take a look at example 2. Same principles apply, so let's go ahead and take a look at it. In example 2, we have the input digits equals an array of integers 2, 2, 8, 8, and 2. The output is the output is 222, 228, 282, 288, 822, 828, and 882. The explanation says the same digit can be used as many times as it appears in digits. In this example, the digit 8 is used twice each time in 288, 828, and 882. So let's go ahead and break this down one step further again. This is just all of the numbers that we can possibly create, all of the 3-digit numbers. This is all of the 3-digit numbers that we can possibly create using these integers that we have right here. As you can see, in this case, we have 202. That's when we just use all of the 2's together. Then we could just use 2 2's and the 8. That's when we get this right here. We can do a 2 and an 8 and a 2. That's a different number, but that's a number right here. We can use both 8, so we could go 288. That's right here. We go reverse that and go 822. Boom, we could go 828 using these two 8's and a 2, and we could go 882. Boom. So let's go ahead and take a look at example 3, where they might try to throw a trick question our way where there are no even numbers we can create. So in example 3, we have the input digits equals an array of integers 3, 7, and 5. The output is a blank array. Explanation says no even integers can be formed using the given digits. As you can see, all of these digits are odd, which means no matter what order we put it in, the last number will always be odd. And if the last number is odd, then the whole number is odd. So that means there are no even integers that can be formed using these given digits. So we have to return a blank array. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get started. First thing we need to do is we're going to create a list of even digits, and we're going to use this to ensure the 3-digit number ends with an even digit. So for this, we're just going to come outside of the class, and we could just say let even digits equal an array of integers, and then we're just going to pass in the even digits 0, 2, 4, 6, and 8. Boom, those are all the even digits between 0 and 10. So if a number ends in any one of these digits, then we know it's an even number. So now let's go ahead and get into function. First thing we need to do is we're going to create a frequency array to count how many times each digit appears in the input. So for that, we're going to come right here, declare a variable. We can call it freq. Set that equal to an array of an array of repeating. So open up the parentheses. There's going to be an array of repeating colon 0. Then we're going to say comma count colon 10, just like that. Then we're going to come right here and we're going to say 4 digit and digits. Sorry, y'all. 4 digit and digits, we're going to say freq square bracket digit. Come outside of that, and we're going to say, come outside the square bracket, we're going to say plus equals 1, just like that. Then we're going to, we're going to come outside of this for loop. We're going to come outside this for loop, and we need to create a variable to store all valid 3-digit even numbers. So for that, this is where we're going to store our output. Boom. So for that, we could just declare a variable, and we call it ands, and we can set that equal to an array of integers. Come outside and put the parentheses, because as you see, our output will be an array of integers. Boom. Now we need to try all possible combinations for the hundreds, tens, and ones place of the digits. So for that, the first digit, the 100th place, must be 1 to 9 and can't be 0 and must exist in the input. So for that, we're going to say for D1 in 1 dot 9 where freq square bracket D1 for our first digit 1 does not equal 0. Then we're going to open up the brackets. Boom. And so we're going to use the occurrence of D1. So we're going to say freq square bracket D1. Come outside of that, we're going to say minus equals 1, just like that. Then for the second digit, which is in the tens place, that can be 0 to 9 and must exist in the remaining digits. So we're going to say for D2 in 0 dot 9 where, equal white space 9 where freq square bracket D2 does not equal 0. We're going to open up the brackets, and we're going to use the occurrence of D2. So we're going to say freq square bracket D2 minus equals 1. Now we need to do it for the ones place. So for that, we're going to come underneath this, and we're going to say for D3 in even digits, because remember, the ones place D3 has to be an even digit for it to be an even number. So for that, we're going to say, just in case y'all ain't know, this is the first digit, this is the hundredths place, this is the second digit, this right here is the second digit, this is the tens place, and this digit right here, the last digit, that's the ones place, and that has to be an even number. That's what we're working on now with digit 3. So we're going to say where freq square bracket D3 does not equal 0. We're going to open up the brackets, and we need to construct a number and add it to the result list. So we're going to say ands dot append, open up the parentheses, D1 times 100. Then we're going to say plus D2 times 10. Times 10. So this is going to get us the hundreds place. This is going to get us the tens place. And for the ones place, we're just going to say plus D3, just like that. Then we need to backtrack to restore D2's count. So we come right here and we're going to say freq square bracket D2. We're going to say plus equals 1. Then we also need to backtrack to restore D1's place. So we're going to come right here and we're going to say freq square bracket D1, D1 plus equals 1. Boom. Then we're going to come right here and all we have to do is say return ands. Now that should be all she wrote, y'all. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Let's see. Okay, sorry, y'all. Equal white space. Let's run it again. See what happens this time. Okay. Oh, I did it again. Equal white space, y'all. Run it again. Let's see. Okay. Well, let's just try it like this. Let's take this white space. Take that white space away. Let's see. Let's run it. Let's see. Equal must have. Sorry, y'all. Trying to see where we don't have equal white space. Maybe it's right. Oh, yep, it's right there. All right, now let's run it, y'all. Let's see. Oh my goodness, sorry about this, y'all. Let's see. Can't find even digit. Oh, sorry, y'all. So let's put an S right here. Let's run it again. All these typos. Sorry about that, y'all. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds. Reach 100% of users with Swift. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.